Hello, Algebra 2. Here we go. This is going to be the calculator portion of your exam. So we're going to walk through how to do this. So these first couple problems, they're asking you to find a particular ratio, and the ratio, the clues to come up with that is this second part. This little part tells you how to label the triangle. This last part tells you where to draw the triangle. So you're going to draw a bow tie in that particular quadrant. So let's start off with this first problem. It's asking me to draw my triangle from 270, which is down here, to 360. So I'm going to draw a triangle that looks like that. Remember, it always comes, your angle comes out of the origin, and the perpendicular always goes to the x-axis. So we've drawn the triangle in the correct quadrant. Now we're going to use the cosecant of theta is, I'm going to put the negative out here in front, 5/3. So cosecant, remember, is the reciprocal of sine, so that's the hypotenuse over the opposite. So your hypotenuse, because it's a radius, will always be positive, which means the negative goes with the opposite side. And that makes sense because your y value is negative. Then you're going to use Pythagorean theorem to find what the adjacent side would be. So we know that a squared plus 3 squared, don't include the negative because it'll be squared, so it's always positive, equals 5 squared. So we know that a squared is going to equal 25 minus the 3 squared, which is 16, so a is going to be 4. Some of you might have right off the bat noticed it is a 3, 4, 5 right triangle. Okay, and it's a positive 4 because x is positive. So that's the one thing you have to pay attention to, is how you label it based on the xy coordinate in that quadrant. Now all you have to do is cotangent. Cotangent is the reciprocal of tangent. So that's going to be the ratio of the adjacent over the opposite. So your adjacent is 4, the opposite is a -3, and that's going to give you your answer. All right, let's try this next one. So we're going to draw our triangle between 90 and 180. So the triangle is going to look like that. Here's your theta's coming out of the origin. And the sine is 1/2, so that's sine is 1/2, which is opposite over hypotenuse. So this is a 1. This is a 2. This one's a little tricky because when I do so I'm going to have my adjacent squared plus 1 equals 2 squared. The adjacent equals 4 minus 1, which is 3. So this is going to be square root of 3, but it's negative because in that quadrant, x is a negative value. That won't come out in the Pythagorean theorem. You just have to know where things are positive and negative in what quadrant. So now we're ready to do our secant. Secant is the reciprocal of cosine, so that's going to be the hypotenuse over the adjacent. So that's going to give me a -2 over rad 3, and we have to rationalize that. So multiplying by rad 3 over rad 3, this becomes 3. So your answer is -2 rad 3 over 3. So that's how you do them. You draw the triangle, figure out the ratio with the given clue, use Pythagorean to fill out the triangle, and then just identify the ratio they asked for. On the second one, kind of the same idea, but you're given just one triangle. And so they are telling you it is 5, -12. So I go out 5, I go down -12, so you want to follow the pattern, draw out my triangle. So remember, it's always coming out of the origin, it always looks like one of your bow ties. So Pythagorean is going to tell me the hypotenuse is 13, but if you're not sure, you can go 5 squared plus 12 squared. That will give you 169, and when you take the square root, that'll give you 13. Okay, so then all we have to do, and if you want to, inside, this is your opposite, this is your adjacent, this is your hypotenuse. Cosecant is going to be the hypotenuse over the opposite. So that's going to be 13 over 12. And I'll just keep the negative out in front. Doesn't matter where you put the negative, just only have one of them. Cosine is adjacent over hypotenuse. So that's going to be 5/13. Okay. All right. Now we are given a triangle with the two given sides, and we still have to find this side. So we're going to do a Pythagorean theorem. We know that 2 squared plus b squared equals 6 squared. So that means that b squared is going to equal 36 minus 4, which is 32. And we do have to take the square root of that. And to get an exact answer, this is the same thing as 16 times 2. So b is going to be 4 rad 2. You might actually find a problem like this on the no calculator portion because I do want an exact answer. All right, so now we're ready to just, here's the theta we were given. So this is the opposite, the adjacent, the hypotenuse, and all we need to do is read off our ratios. Sine is opposite over hypotenuse, so 4 rad 2 over 6. And I write it out here so that we can reduce, because the 4 and the 6 can be reduced. So this is going to give me 2 rad 2 over 3. And my secant is the hypotenuse over the adjacent. So that's 6 over 2, which reduces to 3. Now, to find the measure of theta, that's up to you. I'm going to do a trig on that, and I think I'm going to do the trig that doesn't have a radical in it. We know that the cosine of theta, adjacent over hypotenuse, 2 over 6, so that's the same thing as 1/3. To solve for an unknown angle, remember you have to do the inverse. So I'm going to do the inverse cosine. You can choose any ratio you want. Most calculators only have sine, cosine, tan. So I chose cosine because it didn't have any radicals on it. And when you do that, you should get 70.5, and we round to the nearest angle. So we're just going to call that 71 degrees. All right, now we are doing our conversions. Rewrite degrees in radian, radians in degrees. So I'm going to take 85 degrees, and I want my degrees to cancel, so I put the degrees down here, pi on top, because that's like 1. You can use your, your fraction key on your calculator to reduce just the 85 over 180. So that will give me 17 pi over 36, and then just keep the pi on there. When it comes to b, my preference actually, well, I'll do it both ways. 7 pi over 10, we're going to multiply. We want our pi's to cancel now. So 180 goes on top. So now I can cancel my pi's, and this 0 will cancel with that 0. So it's really just 7 times 18, which is going to give me 126 degrees. I also will sometimes just replace pi with 180. 7 times 180 divided by 10. Notice you get back to 7 times 18. Either way, it works. Okay, next problem we have here is B. We're going to fill out, each one of these is different, so I'm going to do them in different colors. So this one says that B is 34 degrees, C is 16, and I believe I had a mistake on, oh, that's it down here where you want to find B. Sorry about that. And then on this one, we want to find A. So this is, we want to find A. So based on that being 34 degrees, I know this is the hypotenuse, this is the adjacent. That's a cosine problem. So I know that the cosine of 34 degrees is the adjacent over the hypotenuse. So then I multiply through 16 cosine 34, and you just enter that on your calculator and you should get 13.26. Okay, this next problem tells me that the sine of A is 3/5. So actually I'm going to just redraw the triangle over here. And so this is A, this was B, this was C. So sine of A, angle A is here. So the opposite, that would be this side is 3, hypotenuse is 5. That means B is going to be 4, which is what you should have found, not C, because I already gave you C. And then finding the measure of angle B. So that's doing an inverse trig, and you can do it on whatever you want. So if I do a sine of B is the opposite over the hypotenuse, that means B is the inverse sine of 4/5, and that will give you 53 degrees. I believe on the other one I did a tangent. You can really use any ratio you want. They're all nice integers. The main goal is knowing that when you don't know the angle, you have to do your inverse trig, but using the same ratios. Okay? Now, this I know is on the opposite side, but I kind of reorganized this for doing the video. So now we have our graphs where you're going to write a sinusoidal function. And so, and again, it's not going to tell you which one to graph. I find it easiest, if you can, to use the fact that if you start on the y-axis, you have no horizontal translation, so that tends to make it a little easier. Okay, so let's fill out our given information on this. We know that for a vertical translation, we want to find our halfway point. This is really tiny on this screen, so I have to look at my computer here. It looks like this is a -1. I have to rewrite it so I can actually see it. And this is up here at 5. That is a distance of 6. Half a distance of 6 is 3, so that would put me here at 2. So the halfway point is at 2, and my amplitude is 3, because remember, amplitude is that distance from the middle to the high. All right, now my period, we're starting at 0, we're ending at 2 pi. So even though the period is a distance of 2 pi, remember in your equation you're going to go 2 pi divided by the period, that's going to just be 1. And my horizontal shift is none if I do this as a cosine. So this is going to end up being y equals 2 plus 3 cosine. The b value is 1, so I can just write x. Okay? Over here for the next one, I'm going to do this one as a sine because it looks like that starts right in the middle, so that would represent the distance of one cycle. This one looks like it's going up to 3 and down to a -3. So my vertical translation is none. My amplitude is 3. My period, it looks like it takes it a distance of 4 to finish one cycle. So translating that to B is, and again, I don't care whether you use 360 or 2 pi. I'm going to just use 2 pi here. 2 pi divided by 4 is pi over 2. That's what's going to go on the equation. And my horizontal shift again is nothing because I'm starting on the y-axis. So that equation is going to be y equals, there's no vertical, amplitude is 3, sine, so we put in the b value, pi over 2, and x. And that's our graph. Okay, so let's go on to the next page. Okay, so ignore these. They didn't quite make it to the last page. That's fine. Those are the answers to your graphs. So we're going to start off with the amusement park, and I really crammed this in. So I'm actually going to, well, let's see if we can fit it in here. I should have left you a little more space. So the Ferris wheel has a radius of 26 feet. Actually, I'm going to do it way down here. So here's number 8, way down at the bottom. So we have a Ferris wheel that has a diameter. No, this one has a radius. Oh, you know what? I did that wrong. So the radius is 26 feet, which means that would be a diameter of 52 feet. I don't think I read that carefully last time. Sorry about that. And makes 1 revolution in 8 seconds. So 1 revolution equals 8 seconds. Remember, 1 revolution is basically the same thing as 2 pi. So once around. The lowest part of the Ferris wheel is 4 feet off the ground, which makes sense. We don't want to hit our heads. So we're going to have 4 feet here. And we want to come up with the equation. So again, I'm going to just do a quick little graph so we can see how this looks in a linear fashion. So our low point is going to be 4 feet. The diameter is 52, which means I'm going to be up here at 56. Halfway between 56 and 4, those added together make 60, which means 30 is going to be my halfway point. And I'm starting low at 4, and I'm able to complete 1 cycle in 8 seconds. Okay, so how do we turn that into an equation? So I know that my vertical translation, my new sinusoidal is at 30. My amplitude is the radius, so that's 26. My period is 8 seconds, so that means the b value is going to be 2 pi over 8, which is pi over 4. And my horizontal shift is none. But I do want to represent that my amplitude got reflected. So I'm going low to low. So when I go to write the equation, it's going to be y equals the vertical shift, which is 30, minus, there's the reflection, the amplitude is 26. I'm doing it as a cosine because it goes low to low, pi over 4, and then t because we're dealing with time. So to be perfectly honest, instead of that, I should write h of t. I'm not going to mark you down whether you use y and x or h of t and t, so long as you have the right equation. Okay? So that is number 8, which means I have to go back and correct my written practice exam. Okay, so now we're into drawing angles in standard position and finding the reference angle. So the first thing, remember, you're always going to show your initial side. This is a negative 130 degrees. So remember, this would be like negative 90. So 130 would be somewhere around here, as long as you give me a decent estimation. That would be a negative 130 degrees. Now, your reference angle, remember, it's always the distance. So it's going to be this distance right here. You don't have to draw it, but you need to understand what that distance is. So it might help to know that 360 minus 130 is equivalent to 230 degrees. So this is coterminal with negative 130 in the positive direction. So if this is 180 degrees, the distance between 230 and 180 is a distance of 50 degrees. That's going to be your reference angle. It's always positive, always less than 90 degrees. It's the distance to the nearest x-axis. Okay? Doing in radians, finding the reference angle is actually the easy part. You can just pull off the pi over 10, because that's always then going to be less than 90 degrees. All right, so now, how do I graph this? Well, it might help to convert it to degrees. So 7 pi over 10 is one you did on the other page. So 7 times 180, or 180 divided by 10 is 18. 18 times 7 is 126 degrees. So to draw the actual angle, you're drawing 126. Remember, 90 is here, So there's 126 degrees going in the positive direction. And we already have the reference angle, so we're good. Okay, now the last little bit, law sines, law cosines. You are going to want to remember your relationship. Don't write all three out because I find that people get confused when they write. You just want to write at least one proportion. That is your law of sines. So we only use law of sines when you have a pairing. So I'm looking at, I have to find various things. So here's where I'm going to start. So since I'm looking for an unknown side, I like to put my unknown on top. I'm actually going to do this as the reciprocal. So I'm going to write this as A is to sine 42 as C is to the sine of 96. And by doing that, I can then multiply both sides by sine 42, which allows me to cancel it. That isolates my unknown. And this I just enter in my calculator, making sure you close the parenthesis. So 12 sine 42 divided by sine 96, that is going to give you an answer of 8.07. Okay? Now, to solve for B, we are going to have to figure out the measure of angle B, which isn't too bad because it's going to be 180 minus 42 minus 96. Turns out I gave you a gift. That's 42 degrees. So if that's 42 degrees, you have yourself an isosceles triangle, which means that B is going to be the same as A. I can't promise it'll be the same on the test. You might have to set up another ratio, but that's the process you would go through. Okay, now let us solve. Now this one I just gave you a triangle, so we need to label everything. A, B, C, little a is 4, little b, so they go opposite the big vertices. Remember, always, 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 so I didn't really label this. Maybe that would be confusing. Let me go ahead and make sure I label this in a way that fits what we see here. So C is actually our longest side, so let's make that there. That's 6, that's 4, okay. Always find the largest angle first, which means I want to find angle C. So your law of cosines is side angle side, and on the opposite side of the equal sign is opposite the angle. So we're going to start off with 9 squared equals, so we have 6 squared plus 4 squared minus 2 times 6 times 4 times the cosine of our unknown angle. So the bookends are always the angle and the side opposite. All right, so now we want to simplify this, and this is where some people fall apart, so I suggest you just simplify as much as you can. So I have 81 equals 36 plus 16 minus 48, 24 times 2, cosine C. And let's just go ahead and add these two together. So I have 81 equals 52 minus 48 cosine C. And so 81 minus 52 is going to give me 29 divided by negative 48. That's going to equal the cosine of C, and to find C we have to do the inverse cosine of negative 29 over 48. And the calculator will give you 127 degrees. Again, you can round off to the nearest angle. Okay, so that is finding angle C. We now have to find, so we know that angle C is 127 degrees. What that does for us now is that gives us a pairing of a side and an opposite angle. So now I'm going to solve for angle B. Since I'm looking for an unknown angle, I'm going to put that on top. So the sine of angle B is to its opposite side as the sine of 127 is to 9. I do that so that I can multiply both sides by 6. And so the sine of b will be a decimal, 6 sine 127 over 9. That gives you 0.5324. And so we have to do the inverse sine of that decimal. I'm running out of room, 0.5324. And that should give you that angle B is 21 degrees. And to solve for A, I would just then subtract from 180, which will give you 32. Okay, that is the end. Test will be very similar. I'm not going to say it's going to look exactly. It will definitely be a little shorter, but all the main concepts will be there.